last time we were looking at two kinds of problems, right? So I'll give you a kind of a polynomial like this or some function of n, the input size. You want to find what is this equivalency for big O, theta or omega. Or you could find an equivalent data, right? So the two kinds of problems. So we'll do a couple of more. And what we used is called the L'Hopital's rule last time, right? So let's take up this. So we have, say, 3n squared plus 7n plus 4, right? So like I said there, let's find the big O equivalency for this. What is this equal to in terms of big O?
n squared.
How do you say that?
This is where we get n squared is n.
Right. So just see the most dominating term here. Within this expression, it has square root, right? But remember that. So within this, the dominating is n squared, right? And then you have square root of n squared, basically. Okay? So square root of n squared is what? N. So our guess is then something has to be, we have to choose a function that has to be greater than n all the time, right? So let's say our hypothesis is our g of n that we want to use it for big O is n squared. So what we want to find is, so let this be some f of n or some, yeah, you can say it's f of n, right? So what we want to find is limit n tends to infinity, f of n over g of n. And according to our rule, if this is equal to what? If this is equal to what, we can say f of n is big O of g of n. Anybody else? What? So if this is equal to infinity, then this is big O of g of n. Right? So we want to show that. Alright, so limit n tends to infinity. F of n is 3n squared plus 7n plus 4 over n squared. Now, how do you simplify this? Anyone? You have a square root on the numerator and you don't have a square root on the denominator, right? But we can make use of some square root property or some. If you want to write this in terms of square root, what should I write? N to the power 4, right? N to the power 4 is n squared. Okay? So I can write the same thing as what? This n squared as square root of n to the power 4. Okay? So I can write this is equal to limit n tends to infinity, square root of 3n squared plus 7n plus 4 divided by square root of n to the power 4. So why I wrote like this? Since I have now square root in both the numerator and the denominator, I can take basically put everything one square root, right? So I can say this is limit n tends to infinity. The whole thing is square root of 3n squared plus 7n plus 4 divided by n to the power 4. So I'm just putting the whole thing in one square root and dividing the numerator by n to the power 4. Everything. Okay? Any question? Everybody got it?
Can you do it one more time?
Okay, so this is the polynomial and we want to find what is its big O. So big O means some something has to be always, so we want to find f of, like a g of n, right? So given f of n, you want to find the g of n such that f of n is always less than or equal to some constant times g of n. So what is the g of n we want to choose? So I said there can be more than one answer, like in this case too, right? So as long as we find some function g of n that is greater than or equal to our function f of n, we are fine. So we have to do some kind of guess initially to start with. So what we want to do is find the most dominating term inside this function f of n, which is n squared term. So, and we have a square root. So it is like square root of, so you can approximate it to square root of n squared, and square root of n squared is n. So f of n is approximately equal to n, basically. So what we want to find is some function g of n that will be always greater than or equal to f of n. So like we used to do before, we choose a function with a degree higher than this. So since it is f of n is n, we choose our g of n to be, say, n squared. So that's now our hypothesis. Okay, so let our g of n be n squared. So basically now we are verifying whether that is the right choice by using this L'Hopital's rule. Right? So why? Because if you use L'Hopital's rule, limit n tends to infinity f of n to g of n, if this has to be true, if f of n has to be equal to v2 of g of n, the limit has to tend to infinity. f of n or g of n has to be equal to infinity. So that's what we're going to verify, whether this is true. If this is equal to infinity, then this is true. So what we are doing, limit n tends to infinity, this is our f of n, this is g of n. And now to simplify this, what I did, I'm just writing the square, n square as square root of n to the power 4. And then basically something like this. And then I take the whole thing is one square root now, because we have square root in both the numerator and the denominator. Now I can take the n to the power 4 inside. I'm going to simplify this now. So how am I going to simplify this? We have n square, so basically I'm going to divide each of these terms by n to the power 4. Right? So we're going to say this is equal to what? Limit n tends to infinity, square root of what? Hmm? 3 over n square plus
7 over n cubed
7 over n cubed
plus 4 over n 4.
Okay, so now apply the limit n tends to infinity and tell me what's the answer. I'm sorry, this has to be equal to 0, right? Nobody corrected me. Right? If this is equal to 0, it then only means the denominator grows faster, right, than the numerator. So g of n has to, the ratio limit has to be equal to 0. And you see, do we get 0 here? Right. So what does it mean then? If you take a ratio like this, and the ratio tends to 0 as n grows to infinity, it means what? The denominator grows faster. So g of n grows faster compared to f of n. So which means what? We can say f of n is, this thing is square root of 3n squared plus 7n plus 4 is big O of n squared. It could be n cubed. You can choose n to the power 4, anything. Okay, so it just shows the nearest one. You can even choose n to the power 1.5 if you want, but this is more easy to prove because you want to make use of square root property. Okay? So how do we prove this is, so what is the theta of this? What? Theta, some function has to grow at the same rate, right? So by the way, so what this limit has to be now? Right answer. What this to be equal to? Someone. A constant, right? So let's see if we get a constant. So this is what? So what should be our trig now? We have n instead of n squared. So how do we simplify this? We have n. So I want to do something like what we did before and simplify this. So how would you simplify this?
3n plus 7 plus 4n on something. If that's what you want.
Yeah, tell me how do you simplify this? You have n here, you want to take this inside and divide it, right? But you have square root on the numerator and you don't have that. Right now a square root here. So the idea that we did before was we did something to this so that we can introduce a square root and basically the whole thing can be written as a square root. Right? So what would you do here? What you write for this so that I can introduce a square root and then do like what we did before?
The square root of n squared.
Square root of n squared. Why? N square root of n squared is n. Okay? So I can say now this is square root of n squared. Okay? And that would mean make this to be, the whole thing is now square root 3n squared plus 7n plus 4 divided by n squared. So now let's try to simplify this. What this should be. This side. Back side, simplify this. You're dividing each of these three terms by n squared.
3 plus 7 on n
Plus somebody else?
plus 4 on squared.
4 over n square, right? Dividing each of this, 3n square over n square is n square can cancel out, so that is 3. 7n over n squared is 7 over n and 4 over n squared. So now the second row or third row, apply the limit and tell me what should be the answer. Huh? Square root of 3. So what happens to these two terms? 0. Because you're applying n infinity, right? Limit n tends to infinity. So 7 over basically infinity. Anything divided by infinity is what? 0. Anything divided by again infinity square, which is infinity again, right? So that it's also 0. So both these terms tend to 0. So this is square root of 3. That's a constant. Okay, so as I said, you can get any number, even square root of even 10,000, right? So as long as you get some number, that's a constant. Okay? Clear? So we can say what? F of n is, so what happens if we get it as a constant? The ratio is always a constant. So f of n grows at the same rate as g of n. Okay? So that's said to be theta of n, g of n. So this is equal to theta of n. Okay? Clear? Any question? Okay. So if you don't ask question, I'm going to proceed. Okay? So you have to understand and you have quizzes and examples. How would you show what is this is in terms of omega? Anyone? Any guess to start with? This is equal to omega of what? So if I want to do big O, I said n square, right? Then delta we chose n. So logically speaking, if I want to say now big omega, so 1 is not a good choice because 1 doesn't mean anything, right? It's not a function of n. I want something as a function of n. Log n? Log n would be okay, but do you think would be easy to do the thing? If you apply the limit, we'll do that as the next problem, but we can just for discussion's sake. Log n, right? So apply the limit. Let's do that if you want to. Do you know how to do this? No. You can, first of all, if you apply the limit, what will happen? You will get the numerator infinity, denominator infinity, right? So you get infinity over infinity, that's where you have to do differentiation. How many of you have done differentiation in calculus courses? Everyone? No? Should be what? Cal 1, 2, 3, which one they cover that? 1. Everyone are taking calculus 1, right? Yeah. Yeah, so you should have done in high school. Did you do calculus in high school? Differentiation? No? So what you should do is you should differentiate the numerator separately and the denominator separately. Do you know how to differentiate log n? 1 over n, but that is log n. Do you know what is log n? This is log n to the base e. If you differentiate this with respect to n, this is the way you write this, right? Log e to the base n, then that is equal to 1 over n. Okay? Right? But you have here, always in this course, or the computer science generally, when you take logarithm, if you don't specify the base, it's normally the base 2, binary. You deal with binary. Okay? So this is with respect to base 2. So what I want to do is, take down this, we'll use this in the next problem. This is with respect to base 2. So we have to do some trick on logarithms. Because we cannot directly apply this and like he said 1 over n. It is some 1 over n times something. So we want to do some trick and get that 1. So that leads you to logarithms. Have you seen that in your what? College algebra? Yes? So what I'm going to do is because that differentiation can be done only to the base e, I'm going to do something like this. I'm going to write my log n to the base 2 as log n to the base e. This is what we want, but in order to compensate, we have to do something like this. There's a property of logarithms, right? If you write like this, the e is here at the base and this is on the top, so kind of they cancel out and you have n to the base 2. So this is the property of logarithms. Right? You're seeing this kind of property, the base and then the multiplied by the base on the top, and so kind of they cancel out, so n to the base 2. So why I wrote like this? Is this a variable or a constant? Log e to the base 2. It's a constant, right? Why e is a constant? Anybody can tell what's the value of e? Huh? E is what? 2.714 something. It's a number. Yeah. And this is 2, so it's a constant. So if I differentiate this, we want to differentiate this, right? So if I differentiate log n to the base 2 is equal to what? differentiation of this, and a constant can come out, and this is then basically differentiation of log n to the base e. Okay? Clear? And this is log e to the base 2 times now we have 1 over n. Okay? So basically the differentiation of log n, right? So if I don't write base in this course, it is to the base 2. So differentiation of log n to the base 2 is log e to the base 2 times 1 over n. So note that this is a constant. So if I want to do this, I have to do this differentiation for the new denominator like this, and then the numerator, how do we differentiate this? Half what? Half, yeah. So if you have, so let's do that. You want to do differentiation of 3n squared plus 7n plus 4, right? So this is what? The whole thing raised to half, right? Square root means something raised to half, right? So then this is equal to half times 3n squared plus 7n plus 4 raised to half minus 1. That's how we do differentiation, right? Differentiation of something like very simple thing to the n is going to be what? Sorry, not n. N cube, some constant, right? Some constant, say this is going to be 3 times n to the 3 minus 1, right? So the same thing you are doing here, but remember, you are not like implicitly then after doing this, you are differentiating the n. But since differentiation of n with respect to n is 1, we are just writing it as 3 times n to the 3 minus 1, right? But that we have to do this. Implicitly you are not showing that. But here we have to show that. Why? We are not done yet. We have to differentiate what? 3n squared plus 7n plus 4. Then you have to again apply something like this, right? Here, half times this times 2, half minus 1 times that. So you want to do all of this. From here we can differentiate this, right? And then substitute the whole thing for the numerator and then the log stuff for the denominator, then apply the limits. It's going to be complicated. So remember now how the choice of your g of n can make things complicated. So you have to do a good guess. So what was our guess? Log n, right? So you see log n makes it too difficult. And it's a good choice. It's a reasonable choice. It's not a bad choice. You have to just do all the math and then show it is the correct thing. Instead, just let's go with n. So we had n squared for big O, n for theta. We have a square root on the numerator, right? So why don't we choose what? Any guess? I said square root on the numerator. So why don't we choose square root of n? Right? So since we choose square root of n, it becomes easy, right? Because we have square root of n, so I can take the n inside and we can say 3n squared over n plus what? Divide each of these terms by n. So what do you get? 3n plus 7 plus 4 over n. So now you apply the limit, what happens?
So what?
Apply the limit. N tends to infinity. 4 over n goes to 0, so we are fine. So 7 is a constant, but what happens to 3n? Infinity, right? 3 times infinity, infinity. plus something, anything you add to infinity is infinity. So the whole thing is now infinity. So what does it mean? F of n over g of n as n tends to infinity is infinity. Alright? So, which means what? Which grows faster, f of n or g of n? If this ratio is infinity, which grows faster? F of n, right? Because the numerator grows faster. So which means f of n is always greater than or equal to some constant times g of n. So we can say our 3n square plus 7n plus 4 is big omega of square root of n. See here logically this is n, right? So n is always greater than or equal to square root of n. So if you are not comfortable with differentiation, make sure you take down this or take a picture from wherever you are, and this will be useful in this course to do differentiation. Okay, especially with logarithms. And as well as with this, if you don't know how to differentiate a polynomial. Okay? So let's do one more problem. So we're not going to do all the 3 classes now, just theta. So let's do the second one. So if I want to find theta, means I'll give you 2 functions, right? Or so not only theta, it could be anything. I'll give you 2 functions and ask you to find how they are related, which grows faster. Done? So start a sign up sheet. And I will send a lot of updates to Blackboard. I know some of you don't check your JSU email address, so you should make sure you check your JSU email address or log in to that address and do some forwarding to your Yahoo or Gmail or any address. But when I send from Blackboard, it will go only to your JSU address, so it's your job to either check it directly or arrange for some forwarding to your Yahoo private email address. Okay? And already posted a question bank for this module, and then soon post a first project, and then I posted already these videos for last class on YouTube, and I have provided the links in the course website. I believe everybody has visited the course website and seen what is there out there, right? Okay. So the second class of problems, as I said, is what? I'll give you the 2 functions itself instead of making you to guess. I'll give you the 2 functions. I want you to find how they are related. Okay? So that's the other type of problem. So what you should do now, again use our L'Hopital's rule. That's the only tool we have. So we want to use L'Hopital's rule and see how they are related.